on lesson 3 of chapter 8. This lesson is called Special Right Triangles, and this lesson will hopefully make your life easier because you really will not need your calculator at all. You have two triangles, and these are special because they have a special formula. 45, 45, 90 triangles have the formula of x roots of 2. What that means is in relation to their sides, the lengths of their sides follow this special rule. So whatever side is opposite the 45-degree angles, those are x length. And whatever side is opposite the right angle is always going to be x roots of 2. We'll go into that a little bit more in example 1 and apply it with numbers so it's not as confusing as just saying x. Our other triangle is 30, 60, 90. It has a special ratio too, or formula, and that is x roots of 3 and 2x. That means that the side opposite the 30-degree angle is always x units long. The side opposite the 60-degree angle is always x roots of 3 units long. And the side opposite the right angle is always 2x. So what does that mean? Well, that means in example 1, if we have a triangle and we want to know how long a side is, maybe we don't have two of your sides to do Pythagorean theorem. And we do have an angle though, and so we see, hey, that angle is 45 degrees. It follows my x roots of 2 formula. So the first thing I want to ask myself is, what is x? X is always opposite the 45-degree angle. So if this angle is 45, this angle is 90. This angle down here must be 45 degrees also, which means that in our formula, it's 9. So our formula would be 9 roots of 2. So what am I trying to find? I'm trying to find this side opposite the hypotenuse, which is x roots of 2. So looking at my formula, I can see, hey, it's 9 roots of 2. That's my answer. Let's try that with letter B. In letter B, I don't have any degrees, so I can't really look at those, but I can look at my side lengths, and I see that both of these legs are the same. If both of those are the same, the angles opposite them are also the same. So both of these angles must be 45 degrees. So this is another special right triangle that's x roots of 2. And so the only difference is that my x length is 6 roots of 2. Okay, so if this side length is x roots of 2, and this is my x, well, how am I going to figure out the hypotenuse length? Well, I'm just going to sort of plug it in. It's x roots of 2, so I have 6 roots of 2 roots of 2. Excuse me, sorry. So I need to simplify that, and all of you that hated the square roots, sorry, they're coming back. So multiply square root of 2 times square root of 2. 6 roots of 4. Square root of 4 is a perfect square. So this simplifies to 6 times 2, which is 12. Yay! There's my length. Let's try number 2. I want to find A. So 8 is my x roots of 2, right? That's how long it is. A is my x. So if 8 equals x roots of 2, You need to figure out what x is. So let's do some algebra. Divide by square root of 2. I cannot leave a radical in the denominator, so I'm going to multiply by square root of 2 over 2, which simplifies to that. Now, yes, it's tempting to leave it like that, but you need to simplify it. 8 over 2 can simplify. That becomes 4 roots of 2. That's how long my side lengths here are. Okay? Alright, let's try a 30, 60, 90 triangle. 30, 60, 90. I want to find x and y. So remember, the side opposite the 30 degrees is x. So 4 roots of 3 over 3. And this side over here is twice as long. Okay, so let's solve for the y first. Y is twice as long as the side opposite my 30. So 4 roots of 3 over 3. Okay, let's multiply that out. We get 8 roots of 3 over 3. Can I simplify 8 over 3? Nope. So that's my answer for y. Okay, so for x, remember this side is x roots of 3. It's this times the square root of 3. So my x side is this number, 4 roots of 3 over 3, times the square root of 3. Okay, so let's multiply that out. 4 roots of 9 over 3. The square root of 9 is 3. But without a square root. Okay, the 3's cancel out, so x is just 4. Excelente. Alright, number 4. You know that each of these triangles are right triangles. And since this is a square, if I have diagonals, that means that each of these angles are 45 degrees long. So if I draw one of my triangles out at 45, 45, 90, how long is this side right here? If 2 of them are 3 inches, one of them is just 1.5. So if this is 45 degrees, this is 45, that means this leg right here is also 1.5, which makes the hypotenuse what? Remember our right triangle, x roots of 2, so this is going to be 1.5 roots of 2. Okay, we have to justify it, so we're going to write down each triangle is a 45, 45, 90 triangle. So the dimensions are 1.5, 1.5, and 1.5 roots of 2. These formulas that you have down here in your concept summary, very, very importante. Remember them, ingrain them in your brain this weekend because you will need them. Have a good weekend.